कोई product, earlier some product may require 3 months time, but with the help of the AI it can be shortened to, let's say, 1 month. That's it. But it's not like that the AI will do each and everything. We need people to get things done from the AI. Right? So maybe in the future these kind of disruptions are highly accepted. Yeah. Or question? So still the AI lacks, there are so many interactable problems are still there today, and where this quantum will come into picture. So there are problems that cannot even solve efficiently with the help of AI today. A classical example, let's say, this what I call Chakravyuh. That's a simple. Getting out of the Chakravyuh, if you, let's say there are two people, or I don't have that. The maze, Bhool Bhulaiya in Hindi. So let's assume that you have a maze, and there are 50 such points where one can take left turn or right turn. 50 only, let's say. And it is just a perfect square, 20 by 20 something, or maybe some size of the maze, let's say 20 by 20 or 10 by 10 something, let's say. And if you use the classical machine and find the total possibilities from one point A to point B, the classical machine will take hundreds of years. But the quantum machine can do the same thing in few hours or even minutes actually. This is the advantages quantum will bring. A very simple language, just simple example I am giving. Some other examples include like drug discovery is generally considered, designing of the medicines, material design, where some atomic or molecular structure is having several possible combinations, and identifying the right combinations will take lots of time. So this will help basically identifying the right combinations, identifying the right material for particular application, or even sometimes we also called, let's say, personalized medicines. So these technologies will really help in developing a new form of technology or new form of solutions. So if you see, the quantum works in a completely different way. It is not the extension of the classical computing. This is one thing we should understand. It is not the extension, or it is not the incremental stuff or incremental research. It is a completely different domain. It works completely on different parameters, where the traditional computers used to have a 0 and 1, and they are called bits, and the quantum computers worked on the qubits. And I usually compare these today's quantum computers with the initial classical computer called NIT. How many of you know this NIT? Right? Most of you may be familiar with this NIT. In the 60s, 1960s, almost 85 years ago, this is how the computer used to look like. A computer housed in this big hall, highly unreliable, because it was based on the vacuum tube, so these tubes need to be replaced very frequently. It requires lots of amount of electricity also. Also, it is not having, it is not made for the general purpose computations. It was only having some specific need, especially in the defense. So something similar today, I see the quantum computer is something same place. Today's quantum computers are also big in size. They are not for normal use, let's say, for time being. They are also highly unreliable, I can say, because of lots of errors or error definitely with time these quantum machines will also evolve, just like the classical machines evolved, and will be useful in the future actually. So without not going too much in this quantum, actually I'm just coming to so there is one problem actually in the quantum. These since the computing power is so enormous, if you know the recently the Google's two quantum computer, one is called the Sycamore, another is the Willow. So the Willow processor can solve some problem in just 300 seconds. If the same problem is solved by the classical machine, it will take 10 septillion years. थोड़ा सा उल्टा हो गया है, उनका क्लासिकल और क्वांटम को सर्व करना होगा, right? If you are following this correctly, then this classical and quantum को सर्व करना होगा, type of mistake. So what I am saying is a task, a problem which can be solved by the classical machines in 10 septillion years, in the same problem can be solved by the quantum machine in just 300 seconds. Imagine the power of computing. And if it is the case, if we have these quantum computers, useful quantum computers, then all the cryptography or all the security that we use today in your mobile phones or in our digital communication is gone. So if tomorrow somebody comes, okay, I'm having a quantum computer in my pocket, then the very first threat that we see is the digital security or the trust. That is the biggest problem. Because in I think source algorithm is already claimed that if I'm having a quantum computer with these many qubits, I can break the RSA algorithm. So let's say if somebody say, oh, I'm having a quantum computer with 4098 qubits, then all your algorithms, either RSA, ECC, will be broken. Security gone. So lots of research is happening in this domain, and even I also started one startup 2 years back to solve this problem along with two of my students, and we developed some hardware and software solutions for solving this problem. In the last month, this startup was also acquired by a company. So there is lots of potential actually. So with this, I would like to close this, because if anybody is having any question, please feel free to ask. Hello. Please, person वाइफ को की बात कॉल कर रही है तो कुछ बेटा समझ रहे ना, तो क्या प्लीज हाँ
already almost somewhere it is power deficit, somewhere power it is surplus. But overall, if we see the nation, there is a lot of deficit is there regarding the power. So how we can pitch ourselves in the era of this AI, where we are trying to place our footing for the high level AI solutions. So how can we go for this kind of power requirement?
So
our available
So if you see how we are now building our infrastructure, lots of emphasis, lots of initiatives the government is taking in order to develop the infrastructure, which includes power, a good quality power. It is not just power, actually it is a good quality power we need actually. A stable power we need. We need a stable power, we need a good quality power. And I think we are doing quite good actually. Lots of emphasis is also going on nowadays in this unconventional energy, the solar actually. And also working towards this nuclear energy also, some small nuclear power plants, just to meet all these requirements. Because it is, I mean, a kind of a it may have some cascading effect actually, if you see. So if we fail here, then definitely we will not catch those things. This is what happened with the semiconductor also. Semiconductor industry, as we always say, okay, we missed the bus. But now we are trying to build the infrastructure and we are again trying to move. We are making quite good progress in communication actually. Let's say we take, so now we have our own full stack solution available. But earlier we used to, I mean, let's say US and some other countries having 4G, we are still 2G, 3G. But now I think we are moving towards the world, or in parallel to the world in the 5G and 6G, something like this. So lots of emphasis is given in developing these infrastructure, and it is very important actually. So infrastructure is very important actually, if you see across all the technologies. हाँ भाई, आप लोग कुछ पूछेंगे? जितने भी PhD स्टूडेंट कितने हैं? कुछ PhD हैं आप लोग? No? No question? Yeah, please.
Actually, nowadays, like we are moving towards AI-based accelerated to increase competition speed.
Right.
And many of the even biomedical applications also we have started using that. So how this may be helpful for future implementation and how it may be replacing the future technological value.
So ultimate purpose is to make the chips energy efficient.
Yes, sir.
And for that, generally we take, let's say, inspiration from the human brain.
Yes.
How human brain does computations efficiently. And this kind of computation is also called brain-inspired computing or neuromorphic computing. So there are chips, accelerators or hardware AI accelerators. They are based on human brain, like they are built from the neurons and the synapses, and they are quite efficient actually. If we inspire, and such chips are already available. I can name a couple of, like True North, Leohi from Intel, True North from IBM. So they have already building these kind of chips, and they are considered to be quite energy efficient. And if you look at the energy, the main problem in the energy, let's say as a semiconductor, as a VLSI designer, अगर हम बात करें, if we talk, so a significant amount of energy is wasted out in settling the data between CPU, memory, CPU, IO, memory and IO. Today's all your devices, if you take, are based on one human computing architecture. Virtually all machines follow the one human computing architecture. And in the one human computing architecture, there are three major building blocks. There is the CPU or processing unit, there is the IO, input-output devices, and there is a memory. So the data need to settle between all these three units. And during the settling of this data, almost 70% energy is burned only on settling without doing any useful computations, or even more. So this is how, if we can minimize the movement of the data, or the data is locally available, in the human brain, do you think there is a memory, there is a CPU, there is the IO devices? No, everything goes, right? ऐसा तो कुछ है नहीं. So something similar, basically, architecture people are developing, and already some of them are already here. Is it answer your question?
Yes.
Alright.
Thank you.
Thank you.
I request if participants have any further questions, they can ask them.
So could you please explain about quad bits?
Eh?
Quad bits.
Quad,
Quad bits.
qubits.
Qubits.
Qubits, okay. So bits, simple 0 and 1. So you have, let's say, some switch. Either it can be on and off. That's it. No any other possibilities, right? But there can be a representation of information where it is basically the combination of both 1 and 0 also. So qubit is basically qubit represents the information where there is a possibility of 1 and there is a possibility of 0 also. So it is basically a kind of a superposition of 1 and 0. So for example, like I'm here or I'm not here, right? So sometime, so somebody is okay, for example, let's say my students, if my office room is locked, my door is shut, let's say, even it is not locked from outside, then somebody was, sir, might be there inside or sir, may not be there. So the both possibilities are there. I may be inside in the room or I may not be inside in the room, right? But when it collapses, once someone opens the door, so it turns or collapses into classical. So qubits basically they holds this kind of information or the superposition of 0 or 1, yes or no, true and false kind of things. Sometimes these the quantum defies the intuition. Very difficult to follow the conventional intuition. That is the problem. So one can say how it is possible that I can be here and I can be somewhere else. You understand? There is some cat's experiment, or some cat experiment. I forgot what is some Sennon's or somebody's cat's experiment. Schrodinger's cat's experiment. So cat is live or dead? Yes or no?
Yes.
And until unless that box is not opened, we don't know whether it is live or dead. You understand? So qubits are something like this. And now the question is, how do we implement them? We need something basically. This is just a theoretical concept. But how do we implement them? Just like we use transistors, right? Where the 0 and 1 are represented. Your transistor is on, we can say 0. Your transistor is off, we can say 1. So something similar, we need some device. They can represent these qubits. So it is quite interesting, honestly speaking. And sometime conventional intuition fails. Sometimes conventional intuition fails here. So the best part is just accept, because it is have been researched and backed by lots of theory और lots of research. So थोड़ी देर के लिए zoom करके आगे बढ़ जाना है, because it is not theoretical, it is practical. There are quantum computers available, I can tell you, and people are using, and I am also using. IBM has very good quantum computer where anybody can use it actually. Google is having. Microsoft is also having. And there are some unknown companies like Rigetti, D-Wave, Quantinium. So these are another major players in the quantum domain. So let's welcome this technology and let's be part of this technology as early as possible. That would be really good. Otherwise we will again say okay, we missed the bus, or we are late, something like this. It is always good to know. But जितना हम आगे रहेंगे उतना अच्छा रहेगा. So thank you very much. I think I would close now. I'm sure if there is any question.
Participants, if any question you can ask.
All right. So thank you very much for listening me. Yeah, please go ahead. Go ahead. You can speak louder. I can hear.
But sir, we are using AI, so we need lots of data. So sometimes it is very challenging to get data.
Mm-hmm.
So how we can resolve that? And in the field of wireless, like we are moving to 5G, 6G. So real-time data, to get real-time data is very difficult. So how we can resolve that?
So real-time data again, it is basically, let's say, some specific problem. It is your, let's say, some specific problem. I don't know in real time and in the communication which kind of data you are looking for, let's say. So definitely you need to first set up some experiment or set up some
Yes.
right environment from where you can collect the real time data, right? And again you will feed into that model, right? So
Yes. Some security reasons data are not available. So that's why I'm asking how we can get data for research purpose, because we need
so
data.
first of all we should know basically which data it is, kind of data it is.
Data like for wireless communication, for 5G,
While
6G.
communication or say conversation you want to say, like normal people talks, this one?
No.
No, then what would you?
Signal parameters
Which parameter?
like receive power, transmitted power.
So
This
for
thing,
that you develop your
frequency.
own environment test bed. For that I think, or even you can use, IIT Patna is also having some test bed facility for this 5G, 6G. I think you may be also having that test labs kind of things. Agar NIT Patna, Government of India has given 5G labs across various institutions. So you can develop some test bed facilities and where you can get the data, and also you can create synthetic data.
Yes.
Right, synthetic data can also be created. I don't know if then later on some problems may be there, but there is also. All right.
Thank you, sir.
So if anybody is having any questions, please just drop me an email also. Yeah, please go ahead.
So thank you for this nice presentation. I have one question, like what are the threats you discussed for the quantum computing?
Right. So first of all, the quantum computer, the biggest threat is the security today. The biggest threat. So tomorrow is somebody is having the quantum computer, entire security is at the risk. This is what the one threat currently people see, because all your classical algorithms are broken, right? So this is the one threat. I think this is a very nice technology actually. Okay, and the technology has always been used and abused. So there is a very thin line between use and abuse. So, और बताओ, और कुछ?
Thank you, sir.
Yeah. All right, so thank you all.
Thank you, sir.
Thank
For,
you,
sir.
thank you, sir, for this wonderful and informative speech and session as well. So for participants, since we are running a bit late, so may I request all the participants and the present members to move forward towards the amphitheater where the lunch arrangement has been done, and all the parallel track sessions will be resumed after post lunch, that is from 2 p.m. and other keynote sessions as well.